When we change standard abutments, generally shortening the ramp and raising the anchor, we find that abnormal cable angles and forces can result. Abnormal being outside the range we see in standard drawings, which is part of why it is necessary to do these tier 2 checks that we're explaining in the majority of this course. Because of this, we have concerns about the angle of the resultant, and that should fall within about 3 options. The general idea here is that we want the tower load to remain in the Kern limit, which means that the section is completely in compression, ensuring it will not tip over. That limit being within the masonry in the reinforced concrete designed part of the structure. So option 1, the resultant angle causes a moment within the tower column or within the Kern limit, bearing onto the tiers, and this satisfies the check. Option 2, the resultant angle falls within the tower masonry. At this point, it will potentially cause the tower column or the interior reinforced concrete to bear onto the masonry walls. These are not designed to pick up load, as they are hollow, ungraded brick or concrete masonry units. An analysis of section 2.2 of ACI 530 manual is pending, and that would be the future, but for now, this is considered to not pass. Option 3 will result in a completely failed check, and this is when the resultant is so skewed that it falls outside the tower itself. Now let's take a step back to actually perform the check. And first, we need to calculate the resultant angle, allowed eccentricity, and then calculated eccentricity. There's no factor of safety here. We are only checking that the calculated is less than the allowed. First, we can find the resultant angle as the arctan of the horizontal over vertical forces. And this is a schematic. You can find that in the notes section. Next, we find the allowable eccentricity. And as long as you're using a standard tower detail, which you should be, this will always be half of the effective tower depth plus the offset. And finally, the calculated eccentricity will be the horizontal distance from the force incidence, calculated as the column height multiplied by the tangent of the resultant angle. And these dimensions can all be found on the diagram here, which is done for a standard tower detail.